friends, this is my first class on basics and feedback control system. So let me before going on the problems, let me describe some basics and about feedback control system. So what do you mean by basics? Basics means what are the types of control system and what are the different why we need control system, like that. So actually what is that, in every aspect of my life, in every field of my life, we need some type of control. Okay, suppose some child is not reading, okay, then we scold that. Why we are scolding? A scolding is also a type of control. Okay, suppose we are feeling hot, then we need some fan, AC. Okay. So these fan and AC are also controlling our body temperature. So in every aspect of our life we need control. Suppose we want our bike should pick up a speed of 100 km/h within 10 seconds, then we also need some sort of control for that. So in each and every aspect of our life, in each and every field of our life, we need some type of control. So that is control. So sometimes we control manually, sometimes we control through some machine, sometimes we control through some software. So there are so many types of control, and according to the type of control strategy, we subdivide it in different groups. Like suppose we are controlling the speed of fan. So it may control either through either through remote or through by going to its regulator. So if we control the speed of fan through manually going to a regulator, then it is called you can say regulator control. Okay. If you if you control it through remote, then it is called remote controlled fan. Okay, like that. But in both cases man is required. Okay, because in first case man has to go to regulator, and in second case man has to operate the remote. So both of these cases are man-made control. Suppose some system is getting controlled via some software or computer, digital computer, then it is automatic control. Okay, so this is the difference between man-made control and automatic control. There are other sub-categorization. There are of this control system also. Like if suppose we give single input and we are getting multiple output, then it is called single input multiple output system. Can you tell me any such system which is single input and multiple output? Okay, so suppose we are driving the car, then what is the input? Input is like our eyesight, okay, our eyesight and fuel to the car. And what is the output? Output is the speed and direction. Okay, a speed and direction. So this is the case of multi-input, multi-output system. Okay, what is single input, single output system? Suppose a fan, we are giving electricity in that fan. So electricity is the input, we are giving some voltage, so we are applying some voltage across the fan, and we are getting the output as rotation of fan. So rotation of fan is output, and the electricity, or you can say the applied voltage, is the input of the fan. Similarly, suppose we are going for suppose uh, we are giving some input and we are getting more than one output, like we have got in car. Can you tell me such type of example in which we are giving only one input and we are getting more than one output? Missiles. In that we are giving the input as input is fuel only. We are not controlling anything else. So input is only fuel, and we are getting the output as the direction and the what you call distance and direction. Both are required for missiles. So or radar tracking is also a multiple output system. So according to the input and output, there are four types of systems: single input, single output; single input, multiple output; multiple input, single output; multiple input, multiple output system. So according to this is the categorization of system based on input and output of the system. Previously we have done categorization of the system based on whether it is man controlled or it is automatic controlled. Similarly, we can categorize the system whether it is digitally controlled or whether it is analog system. So according to that we can also categorize. But one of the most important categorization is whether it is open loop or closed loop system. So let me explain what is open loop system and what is closed loop system. So before going to the problem, let me explain what is open loop system. Open loop system. Open loop system. A system is said to be open loop if it doesn't depend upon, or you can say the input doesn't correct itself according to the change in output to get the desired output. So its definition is a system is said to be open loop system if the output doesn't correct, sorry, if the input doesn't correct itself with change in output to get the desired output. So what it is saying, if the input is not correcting itself, suppose output is changing, so input must correct, otherwise the system will remain on, and the output will go on changing and changing. Like suppose, can you give me any example of such type of system? Yes, fan is a open loop system. Whatever input you are giving, according to that fan is moving. Fan is not moving according to the situation. Suppose we are getting cold, then the fan will not sense that the temperature of the environment and get its speed slow. That is, we can say fan is a open loop system. Similarly, in most of the in India, at most of the places, traffic light is also open loop system, because it is programmed. It is already running on pre-programmed interval. Suppose the green light will glow for some specified time, then yellow light will glow for some specified time, and similarly red light will glow for a specified time. It will not change according to the output. What is here output? Here the Q is output. Suppose the Q is long, then it is not changing. Suppose Q is long in some direction, then it is not giving more time to pass to handle that traffic, so that the traffic in that direction could be eased. So these are the examples of open loop system. So what are the examples? So examples are fan, traffic light, and generally we denote the open loop system like this. Suppose this is system and this is GS here, this is input RS and this is output CS. We have represented each and every term in Laplace domain. So this is the system, or you can say process, system or process So there is no connection between this is the output and this is the input. There is no connection between output and input. So output is changing according to the input. Input is not changing according to the output, so that we can there should be any control on output. So here this is open loop system. This is open loop system. Here this is output. This is output. And this one is input, and this is a case of open loop system. Okay. Now what is closed loop system? Let me write closed loop system. In open loop system, the input of the system was not correcting according to the change in output of the system. But in closed loop system, what happens? The input corrects with change in output, so that the desired output could be obtained. Like, can you give me any example? Like refrigerator, iron, okay, AC. So AC is also sensing the temperature of your room, the environment, and if it is getting more, if it senses that the temperature is lower than the desired temperature, then the compressor gets off. Then again temperature starts rising. The temperature of room starts rising, and if the sensor sense the temperature has raised above the set point, then again compressor starts to cool down that temperature. So AC, refrigerator and iron, these are the examples of a closed loop system. Our body itself is a closed loop system. How I can say? Because every system in the body, suppose we take the respiration system. Suppose we are moving very fast. Then what happens? We are breathing fastly. Why we are breathing? Because breathing is just involved with the release of energy by metabolism, by metabolization. So we need more oxygen to for metabolization. So we breathe fastly. So that is according to the need. That is according to the change in output. Here output is what is output? Here output is our speed, and here input is what is input? Here input is breathing. So according to the change in output, the input corrects itself, so that the desired output could be obtained. So each and every system in the body, almost every system in the body is closed loop system. So now let me write a system is said to be closed loop system if the input of the system corrects with change in output, so that the desired output could be obtained. What are the examples? So example are as I have already said, air conditioners, AC, iron, refrigerator, etc. our body itself. So how we represent a closed loop system? So let me wipe out this, the above open loop system, so that we could write here. So a closed loop system is represented as, like here, this is the system, or you can say process. This is the process, or you can say plant also, and this is output CS. Here the input is RS. Here the input is, suppose this is input RS. Okay. Now suppose the output is connected to the input through a feedback element. This is the feedback element, or you can say it as sensor also, sensor. So output is connected through the input is connected to the output through the sensor, and some part of input, some part of output is getting feeded back to the input. So input is collecting continuously according to the output, so that we could get the desired output. Okay, this is the case of a closed loop system. This is the case of a closed loop system. Closed loop system. Okay, now I think it is clear to all of you what is open loop system, what is closed loop system. Now what is transfer function? So transfer function is nothing but it is the ratio of Laplace transform of output is to Laplace of it is the ratio of Laplace transform of output is to Laplace transform of input. So here in the question, before coming to the question, let me define what is transfer function. So let me define what is transfer function. So transfer function, let me write here transfer function. So what is transfer function? It is the ratio of Laplace transform of output is to Laplace transform of input taking all initial conditions 0. Taking all initial conditions 0. Taking all initial conditions 0. It is generally denoted by TS. It is generally denoted by TS. So what is the transfer function TS? So TS will be nothing but it will be CS divided by US, where CS is output and US, or you can say RS here also. RS, we can say RS also. So this is the transfer function, and CS is Laplace transform of output, and this RS is Laplace transform of input. Okay. Now here we have used a term initial condition. So what do you mean by initial condition? Initial condition means what is the condition of a system initially, or what is the condition of some component of that system initially. Suppose the system contains inductor, so there should be no current passing through that inductor. Then we say that the inductor is in zero initial condition. Suppose we are having some capacitor, so there should be no voltage across the capacitor at time t equal to 0, means initially. Then we say that the capacitor is having zero initial condition. Suppose so these are the case for electrical system. Suppose we are having some mechanical system like cycle. So the cycle should be at rest at initially. So then we will say that the initial condition is 0. Otherwise, suppose the cycle is initially running with some speed, say 10 km per hour. Then we say that initial condition is 10 km per hour. Initial condition in terms of velocity of the cycle is 10 km per hour. So this is called initial condition. Initial condition means it is directly related to the energy of the system. So initially the energy stored in the system should be 0. Okay. So initial condition, now I think you have understood what is initial condition, and you have also understood what is transfer function. So let me derive the transfer function for open loop system and closed loop system. So what will be the transfer function for open loop system? Let me write here the transfer function for open loop system. So transfer function for open loop system. So suppose this is a system, this is output CS and this is input RS. So the transfer function will be nothing but here. So the transfer function TS will be CS divided by RS, and that will be equal to only GS. So here the GS itself is the transfer function for open loop system. And what will be the transfer function in case of closed loop system? So let me wipe out this so that we could derive the transfer function for closed loop system. Suppose this is our closed loop system. Suppose this is our, it may be positive or negative both. It may be positive and negative both. In case of negative feedback, it is negative. In case of positive feedback, it is positive. So now we can write, suppose this quantity is called here the quantity is called, this is called error ES, and what will be the error ES? So error ES will be nothing but RS minus plus, because we have written this is minus plus, so RS minus plus. Suppose this quantity, this is a feedback quantity, and suppose this quantity is you can say Fs. Okay, so Fs, and what is Fs? Fs is nothing but Cs multiplied by Hs. So we can write here Rs minus plus Cs multiplied by Hs. Okay. Now Es multiplied by Gs, this will be equal to Cs. Now if we put the value of Es as Rs minus plus Cs multiplied by Hs, then so this implies now Rs minus plus Cs multiplied by Hs, this will be equal to Es, and this will be multiplied by Gs, and this will be equal to again Cs. So if we solve it, then we get Cs divided by Rs, that will be equal to Gs divided by 1 plus minus Gs into Hs. Okay, this plus sign will come for if here negative feedback, then plus sign will come. If positive feedback, then minus sign will come. Okay, so let me write here this plus sign for negative feedback, and this minus negative sign for positive feedback. Okay, now it is okay to all of you that this will be the transfer function. So the transfer function, this will be nothing but this will be the transfer function. So the transfer function of a closed loop system will be Gs plus minus Gs divided by Hs. So here the transfer function gets divided by 1 plus minus Gs multiplied by Hs, and there must be some advantage and disadvantage both of using feedback system. So let me write the advantages and disadvantages of using the feedback system. Actually, generally we use one. Let me say one more thing. Generally we use negative feedback, because negative feedback is generally generally positive feedback make the system more unstable, much more unstable. So generally positive feedback is used in oscillators only. So let me write this thing also, and for all other practical purposes we use negative feedback. I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video. If you subscribe my video, then there will be no need to search the new videos. Automatic update will come to you when I upload the new videos. What you have to do, it is very simple. There is a circular logo containing my photo is coming in right of me. You have to just click on that for subscription.